in construction supply chain. Okay, from the title, this is quite practical. Okay, so you're trying to conduct a supplier selection process, and you use AHP combined with Monte Carlo method. Okay, so you combine AHP with simulation, yes?
Yes.
Am I correct? Okay. Okay, then let's start now, please. Yeah.
Okay. Good afternoon, everyone. Let me introduce myself. Myself is Cynthia. And then for this study, my title for the paper is an integrated analytical hierarchy process, which is known as AHP and Monte Carlo methods approach for supplier selection in construction supply chain. Next slide, please. This is the agenda for this study. Next, please. Next. Construction is a growing industry recently in Indonesia. In 2016, the GDP of the construction is increased 53.8% from 2016 and to 2017. This data is based on Indonesia's Central Bureau of Statistics. So the number of construction companies in Indonesia is increasing year by year. So they have to have a good competitive value to keep their existence in existence by having a good supply chain too. Next, please. In construction, it is very common to get all the material, all the tools, and all the equipment bring to site. And then construction, so the construction is category as engineering to order or EPO. Delay in delivery would impact the project duration 50 to 130%, and it can be identically as production and productivity inhibitor. Shortage in material or tools could be lost the labor productivity too. So the supply chain is the important key in construction as well as the supplier selection. Next, please. Now, as we can see in this slide, there are many factors that can affect in construction, such as weather, political, economics, and unpredictable situation during the project can affect the construction process. Now, I give some picture to why is supplier selection is an important things in construction, because if the high supplier selection is connected with cost, delivery, and quality. So in construction, it's equal to those criteria too. So this paper aims to make a supplier selection, need a model supplier selection, which is considered the dynamic condition which have the high uncertainty in construction. Next, please. Next. These are the related works that I do. Much of the related works using only the MCDM method only, but also they have a combination with others mathematical model. Next, please. But as we can see, all the mathematical model is still in the deterministic model, not in probabilistic. And this model cannot fit with the construction condition. Next, please. So in this study, I employ a Monte Carlo method to build a model that gives a simulation under the uncertainty in construction. Next, please. And these are the related work about the Monte Carlo. Some of them really have many in manufacture, but not in construction. Next. So in this paper, I employ two methods. Next. First is analytical hierarchy process, and then the next method I use is Monte Carlo method. The analytical hierarchy process, or AHP, is used for selecting a set of uncertain criteria that can affect the supplier selection in construction. After we get the uncertain criteria, then I make a simulation using a Monte Carlo method to determine to get a model that fit with the condition for supplier selection in construction. Next, please. As we can see, this the very common level of AHP. Next, please. These are the hierarchy structure for supplier selection in my study. So the goal is to get the most effective uncertain criteria in supplier selection, and then it consists of
3 minutes.
Okay. Next, please. This is the conceptual model that I use in Monte Carlo method, which is based on reorder point. Next, please. I put the uncertain parameters in the average demand and average lead time. Then the data that I use in Monte Carlo method is a historical data for formulating the model and doing the simulation. Next. Next. Okay, next. This is the result of the AHP method, and then all the criteria I put in Monte Carlo method. So next. So we can see the result of the Monte Carlo method is shown in table 2. This result is followed by several assumptions, such as I using only the same item. Shortage in this method is not allowed, and then the evaluation of supplier is for 3 months. Next, please. Next. The conclusion. Next. AHP was capable of handling qualitative and quantitative. So I use this as the first method in my study and then to conquer the uncertainty condition in construction, I using the Monte Carlo method. Next. So the future research, I hope that another research can use different hierarchical and detailed objective for uncertain employee with the existing model, and then developing an optimization model to get optimum cost, delivery, and quality. We can use linear programming goals or other methods for optimization. Thank you for your time.
Okay, thank you, Cynthia. So, as a practitioner and researcher myself in the domain of simulation, probably I have like only one question. What simulation offers you then? in this case, in this, what you call it, the supplier selection process, what can the simulation method offer, or what kind of advantage does it give to you?
The simulation method can give a picture about the demand of the project, so we can make a plan, a better plan for the supplier selection, so there's no delay for the project, or not shortage, because the supplier selection is very connected to materials and then tool stock.
Okay. So there's like one aphorism in simulation domain. That aphorism say that, simulation is not about predicting numbers. We're not good at forecasting numbers.
Yes.
If like to do forecasting, you can use simple regression, or even you can use ANP, neural network, probably, or ANN. But when you use simulation, you use that to adapt on how to adapt with the, what you call it then, things that are going to happen in your system.
Yeah.
So it's adapting, not forecasting. Okay. Putri, Vanesha, and Ratnan, do you have any questions? And Fadila, probably, for Cynthia? No question?
Putri? Simple question, Arman.
Please. Yes.
Yeah. Actually, I want to know why you use EHP, because
AHP, okay.
From what I know, there's some subjectivity when you use AHP, because of the weight is created externally, not internally. So what do you think about it?
Okay. Why I using ASP in this study is ASP is quite an old method for MCDM. So I think this method is using a very simple mathematical model, which is can conquer the qualitative and quantitative problems in MCDM. I think in this paper, I need to know what is the what uncertain criteria which is more really affected the construction supplier. I need to know just what is the biggest uncertain criteria which really affect the supplier selection in construction, because that I said before, the supplier selection is critical problems in construction. If the supplier selection do not do the evaluation really good, then the rest of it will chaos, I think.
Okay, that's Cynthia. That's for the answer.
Okay. So probably, I'd like to add something. Why AHP? Yes, Cynthia, I support your, you're saying that AHP is quite robust, old means robust, okay? But the thing is, we have to keep in mind that AHP itself is a quantified qualitative method.
Yeah.
So AHP tend to, you quantify the subjectivity of your objects. So you get respondents, right?
Yeah.
So they have their own probably tacit knowledge. They have their own criteria, and probably they have their own bias, goals or something. And AHP tries to quantify that.
Yeah.
So is it okay to use AHP? Is it okay to use a subjective method? Yes, it is. Since you're talking about decision science. Decision was made by humans, so we need to, tackle or cope up with that. Okay, thank you, Cynthia.
Thank you very much.
And now I'd like to invite Ratna Mira. Ratna Mira, could you please turn on your microphone, Ratna?
Okay, wait a minute.
Yeah. Hi, Ratna. Hello.
Hello.
Yes. Okay, Ratna. Title is Evolution of Supply Chain Resilience, Development of WARE Framework.
Okay.
Well, you know, I just got the proposal from UK about this as well, about supply chain resilience. So I think it's a trend right now, yeah, since all the pandemic stuff. Okay, Ratna, are you ready?
Yes.
Okay, then floor is yours. 10 minutes, please. Yes.
Okay, thank you for the moderator. Good afternoon, everyone. My name is Ratna Mira Yojana. In this time, I want to present my paper with the title Evaluation of Supply Chain Resilience, Development of Risk Analysis and Resilient Evaluation Framework. I called RARE Framework. Okay, next. Okay, the outline in this presentation will be start with introduction and continue with literature review, method for development run framework, and the end is conclusion. Next. Okay, I will start with introduction. The study start from the increased number of complexity in the system because the technology growing. Complexity of the system was cause increase the risks. Risks is the impact of decision that tend not to be like. That's why the company create a supply chain risk management, SCRM, but the realization that not all system can be avoided. That's why company build the system resilient to their risks. Next. Definition of the risks not only rise because the disruption, but also come up because the decision. Contrast with resilience. Resilience is the ability of the system to survive from the risks and return to the condition as before the disruption of have a new normal. Next, please. Okay, the word resilient is used by various fields of science. In the example, in the ecology, the resilience meaning the strength of an ecosystem continue to run normally despite interface. But different within the health and psychology, resilience is the ability of individual to deal with pressure and return to the pre-stress condition before problem occur. Similar with the health and psychology, in environmental and social, resilience is ability of the social ecological system to change and adapt its critical condition of the presence of the pressure. But in the industrial, we familiar heard about supply chain resilient management is both the supply chain with ability to be strong for the risks. Okay, next. Okay, some previous research provide various definition of the resilience. From that, I argue that the resilient evaluation built from three elements. The one is detect, second is respond, and the last is recover the risks from the risks. Okay. Next, please. The ability to detect design with knowledge about the risks and the ability to giving the right response is the key of the success, and the time required to recover affect the amount of loss resulting from the risks. That's why time limit is indicator of their three element resilience. Time indicator specific with the case of the risks. Next, please. Okay, the resilient value measure from three components. One is detectability, respondability, and recoverability. Next. Okay, I developed RARE framework from two perspectives. One perspective is risk analysis, and the second is resilient evaluation. To analyze the risks, one of common method is FMEA. In FMEA, risk score developed from three components: severity, occurrence, and detection. But according to many contemporary papers in the risk management, the value of ability to detect risks is associated with the level of resilience. From that, I deduce that risk score value consists only two elements. There are severity, risk event, and occurrence from the risk agent. Risk event is risk cause the system failure, and the risk agent is the cause of the risk event. Next, please. Okay, to identify the risks in the supply chain, starting with entity in the system, there are supplier, internal company, distribution retailer, and the end of customer. Accuracy in identify the risks will greatly affect to the result of to be obtained. Next, please. Okay, I will to resume my red framework. There are three important sections. One is risk analysis to generate the risk score. Second is resilient evaluation to generate the resilience score. And the third is create a risk and resilience metric to determine the level of importance the risks being to manage. Next, please. Okay, this is my conceptual model of fair framework. Next. Okay, I will explain about the step on the each section. The one section is to analyze the risks. First, we should be defining the supply chain process in every entity to complement the data, and the perspective of the process will be greatly affect the result. After that, continue with grouping the data. The third is identify the details of the process in each group, identify operating risks in each group, determine the risk cause and risk impact. Then the 6 is design questionnaire. 7 is using questionnaire conduct survey involving expert in the supply chain process. 8 is summarize the survey and determine the risk score. 9 is sort the risk score on the deciding order. And the last is select the sorted list risks willing to further evaluation for resilience. Next, please. The next step is evaluation the risks. The component of the speed detect is visibility, awareness, security, sustainability, and SCRM. And the component of response is process-based approach, relation-based approach. And the last is component of the recover are velocity, agility, public-private partnership, adaptability, market position, and information sharing. Next.
You got another 3 minutes.
Yeah, next, please. Okay. And the last is make the risk and resilient metric to plotting the number of risks and resilient value. The metric have 3 categories. There are red, yellow, and green. Red if the danger system, when risk value is higher than the resilience. Yellow is the resilient good enough, when risk value and resilient value is equal. And the green system is top when the risk value is smaller than the resilient value. Next. The conclusion from this paper in the development of the theory and application of supply chain risk, they need to evaluate the resilience of the supply chain system has been identified. Supply chain resilient is supply chain that is designed to be strong and quickly return to the stable if come at the risks. Supply chain resilient is both three components, namely is ability to detect, respond, and recover. The capability is calculated in the term of the speed. Some of the limitation identified inclusion the scoring system, validation, and complexity in its application. All of this need to be considered to the further research. Okay, thank you. This is enough for me. If great for me if any suggestion. Sorry, I cannot hear you. Okay.
Yes, thank you for reminding me. I haven't, clicked the unmute button actually. Okay, Mamira Yojana.
Yeah.
Well, the topic is quite novel lately, because I'm about to submit a proposal by a friend of mine in UK about this to Professor Yuri, your your supervisor, and about risk in our domain, in its most practical level today, when you use risk registry, then you'll be able, or you want to translate it into some financial risk modeling.
Financial. Okay.
Then you can use Monte Carlo method, Monte Carlo method, or probably yes, you can use Monte Carlo then simulation to conduct that.
Unstable signal.
Oh yeah.
I cannot heard.
Oh, sorry, yeah.
So
I'm going
financial what?
And at most practical level, what we conduct nowadays is to translate those risk registry, those identifies risk, into our financial model. And for that, we can use Monte Carlo simulation, as well as, the most novel is VAR, value at risk. So I think, you have an open, wide opportunities to further your research then, Ratna. Yeah. Okay. From the others, from Venetia, Cynthia, and Fadila and Putri, you have any question for Ratna? No question? Nope. Okay, Ratna, please close your presentation. And now I'd like to invite Venetia. Please, Venetia.
Yes.
Yeah. So you have, also 10 minutes to conduct your presentation, and then we're going to close it with the Q&A session. Okay. Venetia, the floor is yours. Yes, please.
Yeah. Okay, good afternoon, ladies and gentlemen. My name is Venetia Dian. Today I'm going to present a paper titled The Conceptual Framework of Inventory Management for Quality Warnings on Perishable Goods. Let's move on to the outline of this presentation. There is an introduction, research question, methodology, result, and conclusion. Next slide, please. The first part that will be explained is the introduction. We know that natural resources such as agriculture, industry, fisheries are very important for human survival. Therefore, the condition of its resources must be maintained so that the benefit its condition can be maximized. Vegetables are one of the agriculture that must be fresh because their characteristic of easily damaged. In other words, vegetables are perishable goods. In addition, perishable goods are very high risk of quality decrease. This research on vegetable suppliers. So, under this condition, time is very important to know the quality of goods use, shelf life, and the storage use. Next slide, please. Move on the background and research question. One of the literature that most closely approached in this research from Dalala about replenishment goods based on the youngest items, meanwhile to fulfill demand, increasingly oldest items. Furthermore, research question, from previous study, how can we observe the quality of goods in detail to know the priority use? ABC analysis used to manage inventory because it helps identify to high priority in the allocation of management time and financial resources. Fuzzy logic as a decision support based on inference reasoning by solving problem is related to uncertainty. The next slide, please. The next part is methodology. ABC analysis can determine the level of importance of product identified. Fuzzy logic has three steps: classification, inference, and defuzzification. One of the fuzzy inference systems used in this research is the Sugeno method. Visual here means post-harvest age, while temperature means the storage use. The metric function here explains the input variable with linguistic. Finally, output optimization here considers the freshness of vegetables. Move on, next slide, please. Move on to results. For accuracy in reasoning, in the process of sorting vegetables, there are fuzzy set values by the membership function. In this research, the value determined according to company condition, how the planting management is carried out, and the storage use. Next, the formation of fuzzy rules related to the expected output. Next slide, please. Yeah. There are 9 combination rules of characteristics from visual and temperature. Make it easier to create rules using tables. For example, here, if the use of low storage temperature with the green color, the color of green vegetables, then it can be defined as a very fresh quality and so on. From this, must have a range value. Can be adjusted based on behavior faced in life, maybe can change according to information and knowledge then implemented. Next slide, please. Sorry, scroll up. In operating this fuzzy with logic n, which means that the minimum value between one membership function with another. Finally, using the weighted average method can be obtained a value that defines quality by knowing the shelf life of vegetables. Next slide, please. The last of this presentation is the conclusion. To summarize, this research used a fuzzy inference system with the Sugeno method, which can help the decision making during the process of sorting vegetable with visual and temperature as input variable, also freshness as output variables. Thank you very much for listening. Sorry, I cannot hear.
I'm so sorry. You know, I forgot to click the mute button. So sorry. So, you know, when we'd like to create a kind of indicators, you know, a KPI for a system, and this thing is the, you know, inventory management for perishable goods, then, you know, there are lots of tools, lots of methods to take, you know. You can easily, you know, use the basic quality tools, the 7 tools. Yes, you can use 7 tools, you know, to create the KPIs. But in your case, you pick fuzzy, yes? Yeah. You pick fuzzy logic. You took the fuzzy approach, which is, well, for myself, you know, is quite novel. So can you tell me, you know, can you tell us why did you take that path? You know, why did you use fuzzy to conduct, you know, your research? Why fuzzy? Why not the other? What does it offer to you?
Because fuzzy can give a constanta.
Mm-hmm.
Yeah, we need to know how the storage use how the storage may be with temperature high, low, medium, and the post harvest age. No. Yeah, according to the specification of the vegetables.
Okay, so this constants means then you can know the state of your goods by having a very, you know, simple and standard numbers, right? I think that's what it offers to you. Yes, simplicity, but it can also, you know, you can also focus on the real or holistic status of your goods. Is it correct?
Yeah.
Okay. Cynthia, Fadilah, Putri, and Ratna, you have any question for Venetia?
One question, okay? Is it okay?
Yes, please, Putri.
Actually, I want to ask, maybe I'm quite skipping your presentation, but where and what is the when and where the function of your ABC analysis, if I'm not mistaken?
The function for to know high priority vegetables when there are many vegetables.
So after the fuzzy, you're using the ABC analysis.
To know what is the priority.
Okay. Yeah. Okay. Thank you.
Okay, sorry. I think I'm mistaken. Okay, Phoenicia, you can close your presentation.
Thank you so
And
much for listening.
yeah, and please do not leave this Zoom meeting because the conference chair would like us to have a photo session. All of us after Putri's session. Yes, Putri. So Putri, you are the last presentation today, the fifth one. The title Multi-Criteria Inventory Classification Model. Yes, Putri? Okay, you have 10 minutes, Putri. Please, floor is yours.
Okay, so good afternoon, everyone. Good afternoon, Pak Arman. For the next 10 minutes, let me present you my research with my research supervisor, Prof. Yuri M. Zahul. My research is about multi-criteria inventory classification model selections based on inventory performance with consideration of forecast downsides. Next. Here are the outline for today's presentation. So I will talk about the introduction, literature review, methodology of this research, results, and the last one is the conclusion. Next. Next. So for the introduction, what is actually the inventory issue in business organization? In business organization, whether it is manufacturing or service organization, they will invest a large amount of capital in inventory. And they will have to deal with many different products. There may be hundreds or thousands of SKUs, even in a moderately sized organization. And they have to keep an amount of goods as inventory in their storage or warehouse. And the last one, they will face a high uncertainty due to the volatility within the market and demand of the product. The number and variety of goods increase with increased demand and also increased corporate activity. So we could conclude that as the size of the inventories increases, maintaining different varieties of product is not easy. Business organizations need to have an effective inventory management through developing inventory control policies. Next. So inventory control policies and what is the relation with the inventory classification? In inventory control policies, they include maintaining an appropriate safety stock level, customer orders fill rate, reorder point, and the key point of any inventory control system are the frequency, timing, and also the order size. So stock keeping unit in a specific inventory control method cannot be applied due to the hundreds or thousands of existing SKUs to manage in the business organization system. Inventory classification system have an important role to achieve the effective management of inventory by helping business organization to developing their inventory control policies. Next. Okay, so traditional inventory classification versus the multi-criteria inventory classification. In the traditional inventory classification, they are using ABC analysis to categorize the inventory items into one of the three groups according to their importance. Class A, the most important one, Class B, the less important, and Class C, the least important. So it's based on the Pareto rules, 80%, 20%. This traditional method usually use only one criterion, which is the annual use value for their classification. So single criterion inventory classification, or SCIC, such as the annual use value, actually cannot generally represent the whole criticality of an item. More practical and effective ABC analysis need to consider not only annual use value, but also various important criteria. So here we are talking about the multi-criteria inventory classification. They will consider more than one factor that can impact inventory classification. Next. So here are the previous research gap, and also the research objective. As you could see, from Ramanathan until the Head Defense 2010, they are focusing only in the classification process. So they're focusing in the ranking, in the development of the ranking method of the inventory items. But they are not considering the service cost performance. They are not considering the inventory performance. As we know, the key point of inventory is minimizing the inventory cost and maximizing the overall fill rate. From Ramanathan to Head Defense, they are not considering that. From Babai to Iqbal, they starting to considering the service cost performance. And in my research, Iqbal actually put one scenarios, forecast upside scenarios, where when the annual demand is actually higher than the the annual demand is actually higher than usual demand. It's the forecast error positive. In my research, I'm considering the forecast error negative when the actual demand is actually lower than usual demand. So there is lack of consideration when the scenario of forecast downside is present in the comparative analysis of the MCIC models. This research analyzes whether there will be any different result in the SCPI between the scenario of forecast upside and forecast downsides. Forecast downsides are considered in this research because in the case of forecast downside, actual customer demands becomes lower than forecast, which creates inventory surplus. This case has a risk of having higher inventory costs. Next. Next. Okay, so we are talking about the optimization model. So I'm not going into details, but if we solve this optimization model, we will get the optimal inventory scores. Next. Next. Yeah, a model is another optimization model. If the R model are not considering the descending ranking criteria, here a model considering the ranking criteria. Next. So Zoe and Van model, they make a composite index between two models, good index model and also bad index model. Next. Okay, so how is the calculation of the service cost performance? I'm not going into details of the formula, but for you to know that there are two inventory parameters that I calculated in this research. It is static stock inventory cost and then the overall fill rate. Next. Next. So according to research by Iqbal in 2017, there are 3 steps to doing the comparative analysis of the MCIC model. The first step is to do the classification by the optimization models that I already showed you. And the next step, after the classification to A, B, and C class, we evaluate the service cost performance to inventory parameters, whether it is the static stock inventory cost and then the overall fill rate. And the last step is to do the hypothesis testing by constructing an ANOVA table by randomized complete block design. In this research, I only do it until step 2. So to continue my research, I will continue to step 3. Next. Next. Okay, so what is actually the classification result? As you can see, the result of each model will be quite slightly different, but not much different, but it's slightly different. So if you go into details to R or Zoe and Van model, there will be the differences in the classes of inventory items. Next. So what is the inventory performance or the service cost performance index? In summary, you could see it in table 1. It's the result of the safety stock cost and also the fill rate in without forecast error, with forecast error positive 15%, and also with forecast error negative 15%. To make it simple to do the comparison, I normalize the value of the safety stock cost and also the fill rate. So the highest value of the service cost performance index means that the R model is the bestest one. So as you could see from table 2 and table 3, there is no differences between the bestest one is for the R model. R model is the bestest one. It's the highest service cost performance index value. Next.
You got so 3 minutes. Oh, okay. Conclusion. Okay. Yeah.
Oh, okay. It's too early. Okay. So my conclusion based on the result is the R model outperforms other MCIC models, whether in the scenarios of forecast error positive or forecast error negative. And our model have the highest service cost performance index value in both scenarios. To know whether the result is statistically significant, author will continue the study by constructing an ANOVA table for randomized block design. Yeah. And this result actually could help inventory managers to designing their inventory control policies. So maybe if for class A, they will be more strict to the cycle counting or maintaining their inventory stock, things like that. So their inventory control policies will not only based on the classification without considering the service cost performance, but also based on this result, they will also considering the service cost performance for different scenarios of forecast error. Okay, next. Here are the references for my study. Next. Next. Yeah, thank you.
Okay, thank you, Putri. Putri, do you work at FMCG company?
I work in distribution company, Pak.
Okay, distribution company. FMCG, no? Or distribution company then?
Distribution company.
Okay. So it's quite interesting because, well, you know, a couple of years ago, I took the basic supply chain management course given by APEX.
Okay.
So although I'm from the simulation lab, so a friend of mine, he offered me, hey, would you like to take that course? So when I took that course, then I opened the very book of inventory management. So then I think, you know, inventory, if I saw, you know, your 5 presentations today, some of you talk about inventory, talk about supply selection.
Yeah.
So it's all about, you know, supply chain, yes, and inventory control. So the mother of any inventory formula is by comparing the storage cost with the ordering cost. Then any model is a derivative from that model, actually, comparing the storage cost with inventory cost. So it's quite, you know, interesting. And I think, you know, although that today, the IE, industrial engineer today, you know, we cover lots of area, but I still believe that this, you know, production and inventory control is one of our core area of IE core area. Okay, Cynthia, Fadila, Vanesha, and Ratna, you have questions probably or comments?
Arman, can I have one question to you?
Oh yeah, yes, of course, yes.
Actually, I'm still continuing this research next term. So I want to know what I could do to make this research better. Whether
okay, to make this research better. So I think, you know, when you would like to apply like one method to a case study, then you'd like to take a conclusion. I think it's better for you to apply it to a couple of data sets. So better for you to use probably more than one data sets. I'm not saying more than two, not, but at least two data sets. And because probably, you know, one industry had, an industry might have its own special character.
Yeah.
Like, you know, you say you're in distribution, right? Like Sukanda Jaya.
Yes.
Well, they're very good in what? In cold chain.
Yeah. Milk, ice cream. Yeah.
Ice cream, yes. And also, you know, my friends in Unilever, they work in the ice cream area. So their logic, their model is quite different from the one who work at probably this Le Mineral.
Yeah.
So like what is Mayora, yes? So they have a different model. So I think different industry will and might give different logic, different set of models. So I think you also need to, you know, to state or also to clear up in what industry you're going to focus on.
Oh, okay.
So you have to pick one, I think, in my, you know, in my opinion.
So maybe in the discussion of my result later, if I'm doing several data sets, so I will comparing the results, right? In this industry or in this industry.
Yes, but better focus in one area that you master, you know. You say that you're in a distribution company, so probably you're in FMCG, or I don't know whether you're in food or probably in logistics, you know, goods. I don't know that.
Yeah.
Okay, so sorry, from where?
In pharmaceutical.
Oh, pharmaceutical. Then you can focus on pharmaceutical. Just focus in that area. I think it will, you know, give you an advantage, I believe. Yeah, Putri.
Thank you.
So best of luck. Oh, could you please, you know, turn on your video, because, well, you know, the session chair would like us to have a picture taken. So all good luck with your thesis, yeah. And I'm also have my